So you can produce static electricity when you rub certain insulating materials together. So for example, here we've got a plastic rod and a wool cloth, and the key feature of both of these is the material they're made from are insulating materials, and what this means is that they allow the charge to build up. What happens is when you rub these two together, then electrons can transfer from one material to the other. So for example, if you had a bunch of electrons over here, and they were to transfer from the rod, so they're naturally in the rod, and they transfer to the woolen cloth, then what happens is you have now a charge on both of your objects. And so the material that lost these negatively charged electrons becomes positively charged, it has an overall positive charge, and the material that gained these negatively charged electrons now has an overall negative charge. So that's how you produce these two materials with charges now. And what happens if you were to take this material now, it's got a buildup of this negative charge, and you were to place it close to an earthed object. So an earth object has a potential of 0 volts. This material, because it's got a charge now, has a certain potential, and what you can say is that there is a potential difference between both of these. So if you could connect a voltmeter, you'd get a potential difference reading between this material, which has a buildup of charge, and this earthed object, which has 0 volts. And that's why when you bring these very close together, you've now got a potential difference, and what can happen is the electrons over here can now actually jump towards the earthed object, and you get what we call a flow of charge. So you've seen that before, and this jumping of the electrons is essentially what we see as a spark. Okay, so this is what happens when you bring a charged object close to an earthed object. You can see the spark, and that spark essentially is that flow of electricity, it's that current. And so this happens because you have the buildup of charge. And an important thing to remember is because the electrons are transferred from one material to another, whatever this gains, this one loses. So if this gains plus 3 coulombs of charge, then this one loses, so it has minus 3 coulombs of charge. Okay, so they all have an equal and opposite charge. And so you've seen what happens when you bring a charged object close to an object with 0 charge. So what happens when you bring two charged objects together? So we can see this in an experiment. Let's say we suspend a ball over here, and our ball, we put a positive charge on it. So you could do this by either static electricity by rubbing the ball and transferring electrons away from the ball, or you can charge it in some other method. But the idea is we have a ball with a positive charge on it, and we can take our rod. So remember, our rod from our previous part had an overall positive charge as well. And what happens when we bring the two like charges together, you end up getting repulsion. So what you'll see here is repulsion, and the ball, because it's suspended on a piece of string, the ball will start to move that way. It will be repelled by our plastic rod because both of the charges are similar. And this is an example of a non-contact force. Okay. And secondly, you could actually change the charge on this rod. So let's say instead of transferring electrons away from the rod now gains electrons, and once again you bring it close to your positively charged ball, then what you'd get instead of repulsion, you'd actually get attraction. So this would be an attractive force between the two. And so now we can replace this with attraction, and that's because opposite charges do tend to attract. So again, it's still an example of a non-contact force, but instead of the motion of the ball being away from our rod, it would then be attracted towards the rod. Okay, so that's how we could see what happens when you bring like charges or opposite charges close together. Okay, so let's go into some questions now. And here's a quick quiz. So question 1, like charges repel, attract, or do nothing? So like charges, we should know they actually do repel, and opposite charges attract. Attraction and repulsion between two charged objects is an example of a contact force or a non-contact force. Well, it is a non-contact force because they don't actually need to be touching to feel that force. And what happens when I rub my feet on a carpet and then get shocked when I touch my fork on the table? So you should be able to explain this now. So when you rub your feet on the carpet, you get a transfer of electrons either from your feet to the carpet or from the carpet to your feet. You then get a buildup of charge on yourself, and then when you touch your fork essentially has a potential of 0 volts. It's essentially earthed, and so there's now a potential difference between you and the fork. And so when you get close to it and you touch it, you end up getting a flow of electricity. And in fact, you might not even need to touch it. Even if you put your hand close to it, you might get the electrons jumping from your fingertips to the fork, and you get this spark, and that is the electrons jumping, and that's again just a flow of electricity because you are charged and the fork is not. Okay, so hopefully that all makes sense, and I'll see you in the next one.